आज हम बात करेंगे expansion of numbers using exponents. What does that mean? See, you know that, for example, I will take an example. See, for example, this is a number 1425, and we know that how to expand this. Okay, we know that 5 is at units place. This is 2 is at tens place. 4 is occupying the hundreds place, and this 1 is occupying the thousands place. Right. So it's actually 1000 means 1. We can expand this 1000 plus 400. 2 tens means 2 into 10, that means 20, plus 5 ones means 5 into 1. Right. So, or you can convert this, expand this in this for 1 into 1000, 1 into 1000, plus 4 into 100, plus 2, since it is occupying the tens place, we can put it like this, 2 into 10, plus 5 into 1. Okay, so which will be equal to this. Okay, that means 1000 plus 400, right, plus 20 plus 5. This is how we expand the numbers. Now we can put it the other way round, that is just like this. 1 into, we know that again this 1000 can be put in the exponential form, 10 raised to power 3. 10 raised to power 3 means 10 into 10 into 10, that means 1000, plus 4 into 10 raised to power 2, that means 10 raised to power 2 means 10 into 10, that is equal to 100. 2 into, since 10 is ones, so that means 10 raised to power 1, plus 5 into, so here is 1, I can put it like this, 10 raised to power 0. So 10 raised to power 0 is equal to 1. Okay, that we discussed in the previous video lecture. Right. Now we are able to, write this number in the expanded form, okay, using exponents. Okay, this is exponential form. What about this number? Okay, this number 1425, here is decimal, and 36. Okay, can we be able to write down this number using exponents? Okay, let's do it. See here, this is this number, ones, tens, hundreds, and thousands. So that means 1 into 1000, right, plus 4 into 100, since 4 is occupying the hundreds place, that's why 4 into 100, plus 2 into 10, plus 5 into 1. Right. Okay. Now there are 2 digits here in this number. There are 2 digits beyond the decimal. So that means the first digit next to the decimal is occupying the place what is called as 1/10ths, 1/10ths. Okay, then the other number 1/100ths, the other number 1/1000ths, and so on and so forth. Okay, so we can put it like this. Okay, then there is plus 3 into 1/10, plus 6 into 1/100. Right. Now let's put it in expansion form, exponential form. Okay, that is 1 into 10 raised to power 3, that is 1000 is equal to 10 raised to power 3, plus 4 into 10 raised to power 2, plus 2 into 10 raised to power 1. Okay, so ones, 10 is ones, that's why. Then 5 into 1 can be put like this. 5 into 10 raised to power 0, 10 raised to power 0 is equal to 1. Then plus, write it here, 3 into 1/10 is equal to 10 raised to power minus 1. Okay, that we discussed in the previous lecture. Okay, then 6 into 10 raised to power minus 2. Okay, so we are able to now able to expand a number using exponents. Let's take another example. The example is 125.6.249. We know that this is units place, or ones place, tens place, hundreds place, and thousands place, th. Okay, then the digit next to the decimal is occupying 1/10ths place, 1/10ths, okay, 1/100ths place, 1/1000ths place. Okay, then okay, let's expand this. 1 into 1000, 1 into 1000, plus 2 into 100, plus 5 into 10, plus 6 into 1, plus 2 into 1 by 10 plus 4 into 1 by 100 plus 9 into 1 by 1000. Okay, so that is equal to 1 into 10 raised to power 3 here, 1 into 10 raised to power 3 plus 2 into 10 raised to power 2 there, plus 5 into 10 raised to power 1, this one, then plus 6 into 10 raised to power 0. Since here is 1, okay, we can put 1 in this form, 10 raised to power 0, okay, which is equal to 1, then plus 2 into 1 divided by 10 is equal to 10 raised to power minus 1 plus 4 into 10 raised to power minus 2 plus 9 into 10 raised to power minus 3. Okay, this is how we can expand numbers, expand any given number using exponents. Okay, let's talk about the first law of exponents. Law of exponents is the next. Let's talk about this first law of exponents. See, I have written here 2 raised to power 3 into. Remember that? This is a operation of multiplication. 2 raised to power 3 into 2 raised to power 4 is equal to 2 raised to power 3 plus 4. That is equal to 2 raised to power 7. Okay, let's check this first. Okay, see, we'll check whether this is equal to this. Okay, let's solve this first. This one first. 2 raised to power 3 means 2 into 2 into 2. Right? Okay, then 2 raised to power 4 means 2 into 2 into 2 into 2. That means 4 times 2. 2 into 2 into 2 means 2 2s are 4, 2s are 8 into 2 2s are 4, 4 2s are 8, 8 2s are 16. Then multiplying this, 8 6 are 48, 8 1s are 8, 9 10 11 12, 128. Right, now let's try to find the value of this. 2 raised to power 7 means 2 is 7 times. 3 4 5 6 and 7. 2 2s are 4, 2s are 8, 2 2s are 4, 2s are 8, 8 8s are 16, 8 8s are 64 into 2. So that is equal to 2 4s are 8, 2 6s are 12, 128. So that means you can see that this, the value of this is equal to 128, and value of this is again is equal to 180. So we can say that this is equal to this. So the first law, it states that when two numbers, say for example, when a number, okay, this is any integer, any non-zero integer, okay, it can be 2, it can be 3 minus 4, raised to power any integer, say for example, m raised to power m, okay. So but point is here the bases should be same. So that means here it is 2, then 2. Then only you can add the powers. Okay. Here base is the same, a, so base is same. So you can put it like this: a raised to power m plus n. So m plus n is nothing but these are exponents. These are powers of the bases. Okay. So that means when the bases are same, these two bases are same, these powers are added. Powers are added. This is the first law of this exponents. Okay. Let's move to the second law of exponents. Let's take another example in order to understand the second law of exponents. Okay, here again this 2 raised to power 4 divided by 2 raised to power 2. That means it is in this way: 2 raised to power 4 divided by 2 raised to power 2. In the previous law, here the operation was multiplication. Now here in this case, in the second law, the operation is division, right? 2 raised to power 4 divided by 2 raised to power 2. Okay, this 2 raised to power 4 divided by 2 raised to power 2 is equal to 2 raised to power 4 minus 2. That is equal to 2 raised to power 2. Okay, let's check this, whether this is correct or not. Okay, let's solve this one. 2 raised to power 4 means 4 times. 2 raised to power 2 means 2 times. Okay, this 2, they will cancel one another. And there remains 2 and 2, that is equal to 4. Okay, now here, in this case, 2 raised to power 4 minus 2, okay, that's equal to 2 raised to power 2, that is equal to 2 into 2, that means 2. So that means this 4, okay, the value of this, okay, is 4, and value of this, okay, or this, that is equal to, again 4, you can say that this is equal to this number, 2 raised to power 4 divided by 2 raised to power 2 is equal to 2 raised to power 4 minus 2, that is equal to 2 raised to power 2, okay. So we can put it in a general form. Say for example, this a raised to power m divided by a raised to power n, that is equal to a raised to power m divided by a raised to power n. Okay, so you can symbolize the division operation of division in this way or in this way, right? So this is equal to a raised to power m minus n. So in case of a division, the powers are subtracted, but in case of multiplication, the powers are added. Okay, but the provision is that the bases should be same, right? Okay, let's move to the third law of exponents. Okay, see here, you can see that it is 2 raised to power 3 whole raised to power 2. In this case, when the number is provided the two powers, okay, 2 raised to power 3, here are two powers of the number of the same base, 2 raised to power 3 whole raised to power 2. So in this case, what happens? These two powers, they are multiplied. Okay, so that means 2 is equal to 3, 2, this is equal to 2 raised to power 3 into 2. That means 2 raised to power 6. So we can put it in a general form. For example, this is a raised to power m whole raised to power m. Okay, whenever you get the expression like this, so what you have to do is to multiply the powers. A raised to power m into n, that is a raised to power mn, right? Okay, so this was the third law. Now let's move to the fourth law. Okay, you can see that here in this case it's 2 raised to power 3 times 3 raised to power 3. Here bases are different, but what is same in this expression? The powers are same, 3 3. In this case, what you have to do is to take this power common to the both bases, right? Okay, so we can check this as well. 2 raised to power 3 means 2 into 2 into 2 into 3 into 3 into 3. 2 2s are 4 2s are 8. 3 3s are 9, 27. 8 7s are 8 2s are 16, 17, 18, 19, 20, 21. Right. Okay, then here 2 3s are 6 raised to power 3. That's 6 into 6 into 6. So that is equal to 216. Okay, so we can put this. Okay, so the value are the values are same. So we can put this in a general form: a raised to power m plus b raised to power m, not plus, it is into. Remember that. Okay, this law is only applicable when there is the operation of division, this multiplication. Then it is a raised to power m times b raised to power m is equal to a into b. That means ab raised to power m. That is called ab raised to power m. Okay, this is the third law of the exponents. Sorry, it was the fourth law. Now fifth law. Fifth law is, see, it is similar to the one which we discussed a minute ago. That is, say for example, it is 2 raised to power 3 divided by 3 raised to power 3. Okay, so we can put it like this: 2 raised to power 3 divided by 3 raised to power 3. Here these are different, but the powers are same. So you can put it like this: 2 divided by 3 raised to power 3. So that means in this case bases are different, but the powers are same. You can put it like this. Okay, in general we can put it like this: a raised to power 3 divided by b raised to power 3. So this can be put like this: whole raised to power 3. So that means this 3 is exponent of both a and b. Okay, this is the fifth law. Now the laws. Here it is any number, any integer, when it is raised to power 0, that is equal to 1. Okay, that we discussed in the previous video lecture how it is possible, right? So we can put this in a general terms. It's a raised to power 0 is equal to 1, right? Let's revise all the laws together. Okay, this is the first law. Okay, base are same, powers different. Okay, the operation of multiplication, a raised to power m times a raised to power n is equal to a raised to power m plus n. Okay, this is the first law. Second law is, in the bases are they are in the operation of division. Bases are same, powers different, then they are subtracted. Powers are subtracted, right? Okay, when they are the two powers of the same base, okay, then the powers are multiplied. Okay, when the power is same, base is different, operation is division. Okay, then the power is taken common. Okay, these two are multiplied. These are multiplied. These are multiplied, right? The power is taken common, right? Then here is the operation of division. Here these are divided. Okay, then the power is taken as common, right? Okay, we can put it in this form as well: a divided by b raised to power m, and a raised to power 0 any number. Okay, raised to power 0, that is equal to 1, right? Okay, this is all about the laws of exponents. Take care.